The lesson topic for this video is review of properties of exponents. Okay, so the first thing I'd like you to do is pause the video and just number your paper somewhere on your notes 1 through 8. Notice I did skip number 3, don't worry about that. And try to just simplify each of these power rules or exponent rules to see if you know them. Then restart the video to check how you did. Okay, so the first one is a to the 0 power. Hopefully you remembered that anything raised to the 0 power is 1. Whoa, that's really thick. All right, 1. It's not it's not a to the 1, it's not 1a, it's just the number 1. The second one, since you have a negative exponent, I'm going to put this whole thing over 1 to help me remember that I'm going to make a fraction. And now I'm going to decide if I'm going to move something and make the power positive or keep it where it is. Since a to the negative n has a negative exponent, I'm going to move the a to the bottom of the fraction, the denominator, and make the power of n positive. Now I'm going to fill in the numerator because this is a 1 right here, That's a 1, so we're going to go ahead and fill a 1 in the numerator. So 1 over a to the n. The next one is called the product rule. A to the x times a to the y means we keep our base of a and we raise it to the x plus y. Okay, the next one, a to the x power over a to the y power. Since this is the quotient rule, we are going to subtract our exponents. So we leave our base of a and we subtract x minus y. The next one, the power rule. If we have a single base of a raised to the x power and then raised again to the y power, we keep our base of a and we multiply the exponents. So x times y. The next one is the power of a product rule. And I talked about this in class and in some examples. I didn't explicitly write it out in your notes, but we talked about what this means is we need to raise a to the x power, and we also need to raise b to the x power. And the last one is the same idea here. We're going to raise a to the x power, and we're also in the denominator going to raise b to the x power. Okay, and again, since this is a review of the properties, you might want to pause the video, try these on your own, and then restart it to see how you did. Or if you feel more comfortable just watching me walk through them, that is, of course, your choice. So number 1, negative 5 times y to the negative 2 times z. Okay, so anytime we have a negative exponent, my strong recommendation is to make this into a fraction right away by putting a denominator of 1 in there. And now I'm going to decide on whether I keep things or move things, because I don't have any outside parentheses with an outside exponent or anything. So all we need to do in this situation is decide if things stay or move. Negative 5. This is a very common mistake. People like to move negative 5 because it's a negative number. We do not move negative 5. Negative 5 stays where it is because it does not have a negative exponent. The exponent on a negative 5 is a 1 right there. Y to the negative 2 does have a negative exponent, so I'm going to move it to the denominator, and I'm going to make the power positive. Z has a power of 1 as well. It's not a negative power, so I'm going to put a z in the numerator. This is as far as I can simplify this problem. Number 2, 1 over 4 times x to the negative 3. Again, we have negative exponent, so I always like to make sure to keep that fraction bar there. The 1 is obviously going to stay where it is because it doesn't have a negative exponent. The 4 is also going to stay where it is. Again, this 4 has a 1 as an exponent, not negative 3 as an exponent. The x is the factor that has the negative 3 exponent, so we're going to move that and we're going to make the power positive. This is the final answer. If you wanted to not write the 1 in there, you could, but otherwise it's fine the way it is. Number 3. 2x over 3, all raised to the negative 3. So the first thing that I would do here is I would make sure that every single factor in the parentheses gets the exponent of negative 3. This includes the 2. So 2 to the negative 3, x to the negative 3, whoops, I'm writing a 4, hello, 3, all over 3 to the negative 3. Now, before I start thinking about doing 2 to the negative 3 on my calculator, please don't do that. We're not going to raise 2 to the negative 3 on our calculator. We're going to first make sure we get rid of all negative exponents. Okay, so I'm going to say equals, put my fraction bar, 2 to the negative 3. It has a negative exponent, so I'm going to move it. I'm going to make the power positive 3. X to the negative 3. I'm going to move that to the other side of the fraction, and I'm going to make the power positive. In the denominator, we have 3 to the negative 3 right here. It has a negative exponent, so we need to move it to the other side of the fraction, so to the numerator, and make the power positive. Now we're going to simplify our exponents. So 3 to the third power is 3 times 3 times 3, right? 3 times 3 is 9, and 9 times 3 is 27. So we have 27 over 2 to the third power is 2 times 2 times 2, and 2 times 2 times 2 is 8, and x to the third stays there. 27 and 8 are not both divisible by the same number, so we're not going to simplify this fraction at all. So that is our final answer. The next one, 12 to the 0 power times x times y to the 0 power. Again, notice x has a power of 1 right here. So first of all, 12 to the 0 power, anything to the 0 power is the number 1. So this right here is the number 1. X to the first power just stays x to the first power, which is x. If we want multiplication between there, we can. And y to the 0 power, again, anything raised to the 0 power is 1, so times 1. 1 times x times 1, well, that's just x. And the last one. Again, the first thing I would recommend that you do is take care of dealing with any exterior exponents here. Here's parentheses. We've got an exponent that needs to be given to every single factor here. So a squared is being raised to the negative 2, and b to the fourth is being raised to the negative 2, and c is being raised to the negative 2. Okay, times, and again, all this was being multiplied as well, times a b squared and times c squared. So again, a long strand of multiplication here. All right, so the first thing I'm going to do is take care of my my a raised to the second power raised to another power. Again, I want to take care of these exponents that are on the outside of parentheses. So I'm going to rewrite this again. I'm going to rewrite this as a to the negative 4, because I multiply these exponents when they're in the power rule situation, times b to the negative 8 times c to the negative 2 times b squared, make that a times sign, squared, times c squared. Now I finally get to the point where I can use my fraction and decide if things are going to move or stay. A to the negative 4, I'm going to move it, and I'm going to make my power positive. B to the negative 8, I'm going to move it to the other side of the fraction and make my power positive. C to the negative 2, I'm going to move that to the bottom of my fraction and make the power positive. B squared, right here, has a positive exponent, and so it's going to stay where it is, so b squared, and c squared as well has a positive exponent, so it will stay. Now, we're going to simplify one more time and we'll be done. Notice that we have base of b in the top and base of b in the bottom, and we have base of c in the top and base of c in the bottom. So we only have one base of 4, so I'm just going to leave that where it is. It doesn't have a negative exponent, it's just going to stay right there. But where do I have more b's? I have b squared here, which is b times b, and I have b to the 8th down here, which is b times 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 b. Well, where do I have more b's? I have more b's in the denominator. If I were to expand this out, I'd have b multiplied the other 8 times, and expand this out, I'd have b times itself twice, which means I will have b to the 6th in the denominator. And now where do I have more c's? Well, my c's actually cancel each other out. If I have c squared in the numerator and the denominator, they cancel. I'm going to fill in the numerator with a 1, and here is my final answer. That one took a little while. All right, go ahead and watch this again if you need a little more practice, or try them on your own and then check back again. Thanks.